Alright, here's the second video on the building function standard, Spring 2019 Math 3 final review. Remember, all these videos are not all-inclusive. You're responsible for learning everything that we've learned for all these standards throughout the entire year. Okay, real quick video for this one. Let's see. What equation is represented by this graph? Let's talk about this graph. And we need to understand, and always, for trig function graphs, always analyze amplitude, period, phase shift, and midline. Okay? So right off the bat, I hope when you look at this, you should see, and looking at the answers, your answers on the final may not be multiple choice, so take that into consideration. So we've got some tangent and some cotangent. Yeah, that makes sense. This is tangent and cotangent. What did we say on the prior IF video about tangent and cotangent? Tangent, we know, is always increasing. We're going left to right. This is always increasing. So it's not going to be B or D. Now, what else do we know? Is this have a midline? It looks like the midline where it's going through 0 is at the origin. So our midline is not going to help us. We know it's tangent. What else can we look at? Phase shift. We know tangent is 0 at 0, so there's no phase shift. It's not moved left or right, so that's not going to help us. It looks like the only thing that's going to help us is amplitude and period. And what is the choices for A and C? That's showing amplitude is 1/2, and this is showing the period is being changed because that's the B coefficient. Now remember, for tangent and cotangent only, in a previous video you saw that sine, the period is going to be 2 pi divided by B. That's because the period of sine is 2 pi. Well, in this case, because the period of tangent is pi, so you can figure out what the period of the function is by doing pi over B. Okay, so what is our period of this graph? Well, let's go from repeated points on the y values, 0 to pi. So the period of this graph must be pi. So we're going to say that equals pi. Well, doesn't that mean that it over 1? Doesn't that mean B equals 1? So B has to equal 1, so that means that cannot be the answer. So this one has to be the answer, and let's check to make sure. Yeah, you see how the little inflection line there, there's 1, there's 1/2, where it changes slope. That's where the 45-degree line is, or tangent of pi over 4. Okay, so that's how you figure out that this one is A. Our graph is y equals 1/2 tangent x. Hopefully, going through all that analysis based on your graph, you can pick out what the equation is. Okay, that took a lot longer than I thought. So let's talk about finding the inverse. Same thing we did up here. We're going to set it into a y equals format. So y equals log of 2 to the x. Now we're going to switch places because inverses, the domains and range swap because it's a reflection over the y equals x line. And now we have to isolate y. Now here's the kicker. For exponentials, you got to remember logarithmics and exponentials are inverses of each other. Remember, there's an unwritten base right there. It's 10. And to go from logarithmic to exponential, you go swirly. You send the log down the drain. So it's 10 to the x equals this stuff. So 10 to the x equals this stuff. 10 to the x equals 2y. Okay? Now here's a mistake a lot of students made on the test. When you divide by 2 to isolate y, you don't divide this 10 by 2 because the exponent acts first. So you're going to be dividing this 1 by 2. So it's actually y equals 1/2 times 10 to the x. And that's how you find out the inverse to any logarithmic. And of course, you can go back and forth to an exponential. All right, that's it.